So in .NET, most famous language is C#. Currently, for many people, when we say .NET, .NET is only associated with C# for many people. And C# was developed in 2002 by this guy and Microsoft, and it is very famous, and it's very famous language, and its popularity is increasing as time goes. And a history that I know behind the C# is that in 2002, Java was most popular language during that time, and almost everything was being built in Java, and Java had many fans, including Microsoft, and Microsoft liked this language so much that they decided to buy it from its creators. They wanted to make it as a Windows-only language, an exclusive language for Windows users. And creators of Java rejected this sentence, this offer from Microsoft, because they said that Java was built for multi-platform and it is free for everyone to use on any platform anytime. And after this, Microsoft decided to make their own version of Java. They copied everything from Java, added many cool features, and called it C#. So basically, they took every cool features from Java, also from C++, also added some SQL query syntax, and made the combination of these languages into one language. So basically, that's the history that I know behind the creation of this issue. And let's move to the next topic, that is DevOps. So basically, DevOps is a set of practices and cultural principles that aim to kind of bridge the gap between the development and between the development and IT operations. So it underlines collaboration, communication, and also automation to streamline the software delivery process. It actually increases efficiency and it improves the overall quality of the software systems. And for today, I just included two topics that are continuous integration and continuous delivery. First of all, we'll start with continuous delivery. Continuous delivery is the practice of automating the software release and also the deployment process to enable frequent, reliable, and risk-free, not risk-free, but low-risk software releases. And with continuous delivery, software is always in a deployable state. It allows quick and efficient deployment to various environments. And there are many amazing tools for implementing and doing continuous delivery, such as Git Actions, Jenkins, and also Azure DevOps, and there are some others. And I believe it's all about continuous delivery, basic overview. And the next topic is continuous integration in DevOps. So basically, continuous integration is the practice of frequently integrating code changes from multiple developers into a shared repository. And with continuous delivery and continuous integration, each code change can triggers an automated build and testing process to kind of identify integration issues and problems in the early stage. And with continuous integration, we can do tests during deployment, and it is very, very useful tool. And at the end of the presentation, I will discuss the solid principles, a set of design principles that help developers create robust, maintainable, and scalable systems. And these principles guide us in writing clean and kind of modular code. And there are 5 principles united in one word that is solid, and each character stands for some principle. First letter is S, which stands for single responsibility principle. And this principle states that a class should have only one reason to change, and it suggests that each class should have a single responsibility or purpose or motivation. And by following this principle, we can achieve code that is focused and also easier to understand and less prone to bugs. And the next letter is open-closed principle. And this open-closed principle emphasizes that software entities such as classes, modules, or even functions should be open for extensions, but closed for modifications. Basically, it means that we should design our code in a way that allows us to add new functionality without modifying existing code. So this open-close principle promotes code reusability. It also reduces the risks of introducing bugs in the code and uses easier maintenance. And the next letter is L, and L stands for Liskov substitution principle. It was created by a developer who was Barbara Liskov, and this Liskov substitution principle states that objects of a superclass should be replaceable with objects of its subclasses without affecting the correctness of the program. In other words, derived classes, child classes should be able to be used interchangeably with their base classes. And following this Liskov substitution principle helps us to create a consistent and predictable behavior in our code. And this enables better modularity and also extensibility. And the next letter is interface segregation principle. And it stands and it suggests that clients should not be forced to depend on interfaces and do not use. It promotes the idea of creating interfaces tailored to specific client requirements. And by following this interface segregation principle, we eliminate interfaces that are not needed. And this principle leads to more maintainable and flexible code. And the last principle is solid, is dependency inversion principle, and I believe that is the most hardest one. Lots of developers do not know about this. They cannot explain what this principle is. And this D stands for dependency inversion principle, and it states that high-level modules should not depend on low-level modules. So in other words, they should depend on abstractions instead of concrete implementations. So basically, it promotes loose coupling between modules and encourages the use of interfaces or abstract classes to define our code structure and also the dependencies. And this dependency inversion principle allows for easier testing, better modularity, and promotes code that is easier to change. I mean, the code that is resistant to changes, and it won't break after a couple of changes. So for today, that was all. And thanks for listening. And if you have any questions, I encourage you to ask me. We can continue talking.
Hi, Dachi.
Hello.
I have a question that how can we start our journey in .NET?
If I heard correctly, the question was how to start .NET development. Yeah.
Yeah,
So basically, you can first of all learn a language called C# that I mentioned during the presentation. After learning, if you know Java, basically it is very, very similar to Java, this language C#. And after learning C#, you can choose the direction. If you want web development, you can then learn ASP.NET, or if you want desktop development or mobile development, you can learn MAUI that I mentioned, or Xamarin. Xamarin is basically all the version and it is not actively used. And yeah, if you want to develop games, C# is also very, very nice in Unity. And so basically my first recommendation is to learn the C# language syntax. And after that, you can start learning ASP.NET or Unity or specific framework. So there are many books about C#. I recommend books, but also there are many tutorials in YouTube or also on Udemy or Plural site or on some other websites that you can watch and learn.
Hey Dati, how your coding journey started and how you started learning coding? Uh, what
Yeah,
are
so yeah.
your present position in software development field? How you achieved some this expert in .NET?
So I started learning programming approximately 8 or 7 years ago. I started learning in IT Academy. It is organization where they teach people programming, just basic programming. And after learning, firstly I learned the language C, then I learned C++, and after that I started learning C# by myself. And when I learned C#, I was like 15 years old, and I started the internship in one company that is GPA Holding. It is insurance company in Georgia, and during that internship, I learned lots of things. I also taught programming in that organization in IT academic staff. And I was teacher there, and I was teaching C#. And when I turned 18, I passed in university in Kutaisi International University in Georgia. I learned more things in university about programming and computer science concepts. And on the first year of studying, I started working in one Georgian small company that was called Walkers. In that company, I learned lots of things. There we were developing Unity games, and we developed one of the famous game in Georgia that is called Simple Logic in English. And it had like 1 million downloads in Georgia. Actually, the Georgia's population is 3 million people, and we developed a game that was downloaded by 30% of the population, and it was very famous. And after that, I started working as a senior full stack developer in my current company in Fedrock technology, and I'm working on React.js part and also with .NET backend. So idea is to learn computer science concepts very well, starting from databases to maybe front-end part if you want to become full-stack developer. Yeah, I think that was my history, how I started. Do you have any other questions?
Is there any pre-requirements for C#?
What kind of requirements? Like in terms of knowledge, you don't need any prerequisites for starting C#. If you do not have any experience with C# or programming, you can directly start learning programming using it is easier to compare to C or C++ or any other languages. So basically, there are no requirements and you can start from zero.
Yes, I think.
Hello?
Yeah. Have you have any idea about open source contribution?
Can you repeat?
Have you have any idea about open source contribution?
Open source contribution?
Yeah. Do you have any ideas like how to contribute and what is the future if we contribute in good open source companies? Can we get a good jobs after contributing in open source?
So basically, there are some open source projects that you can find on GitHub. And on GitHub, there is issues created, the tasks that should be done. Some people create these tasks, and you can take one of the tasks, and you can start working on it. And after you complete it, you can make a pull request. Other open source developers will review it, set your changes or your code, and they will approve it to be merged. And yeah, it is very, very welcomed to contribute on open source projects. You can put it in your CV. There are basically many great projects. For example, Linux is open source project, and many other projects. So I encourage you to do so because it is appreciated by the companies when they see in the CV.
Today, and thank you for accepting my invitation and joining us in this item.
Okay.
Really, your coding journey is inspirational. And
I can. Yeah.
we will end up this sessions today.
Can you repeat? So
we will end up this.
Okay, sure. Okay.
Yeah.
And if you have any questions, guys, I will send you my LinkedIn URL, and you can ask me questions here. If you have any questions in the future, I'll put my LinkedIn URL in chat, and you can make a friend request. You can connect with me and ask me some questions if you have any. Okay, thanks for listening, and yeah, we can end for now.
Thank you, Daji. Thank you so much.
Goodbye.
Thank you very
Thanks.
Thank you everyone for attending this session today. So we can leave this session.